So yesterday what we said was logarithms are exponents. Logarithms are exponents. There are some exponent rules that we can apply to logarithms since they're exponents. One of them is if you see multiplication, you can add the exponent. So 2 plus 4 is 6. So if you see multiplication and logarithm, you can do what we call expansion, where you separate them with addition. So multiplication in the argument means you can separate them with an addition sign. Division in the argument means you can separate them with a minus sign, because when you divide, you subtract 4 minus 1. So they go together, division, subtraction. The third rule we said was if you raise it to a power, if you see a power, you're going to think multiplication. We multiply these to get 10. With the logarithms, we change it to multiplication. So it looks a little bit different, but the exponent, if you see a power, you can move it to the front and it looks like multiplication now. So we said all of that because we went over Khan Academy and started this lesson, but we didn't get far enough to do enough that I wanted you to practice. So let's do some more today where we see a logarithm. We can expand it into all of its different bases, and then sometimes we can simplify a little bit, and then we can go in reverse. So we can get one that's separated. We'll see addition, and that we'll think multiplication, or we'll see subtraction, we'll think division, whatever it is. We'll see if we can apply it to our logarithm. So we just reviewed the properties from yesterday. This is that same page. Today we're going to do example 2 and just do some more of these so we can simplify. So this time we're going to say we have a log, base A, meaning it doesn't matter what base it is, but I'm going to write a big cube root and put some stuff in it. On the top will be xy squared. On the bottom, z to the 4th. So the reason I'm learning these rules is so that maybe I can simplify some stuff. In this case, they're all different variables. I probably won't be able to simplify. I just want to be able to see the rules very separately. So first of all, I want us to note that xy squared over z to the 4th is all in this cube root here. And our rules only deal with addition, subtraction, and multiplication or powers. So let's change this power, this cube root, to look like a power. What would that be? What would the power be if it's a third root? Am I going to put a cube here or something else? So we think it's like a cube, but it's different. It's not -3. What is it? What's the exponent? 1/3. So when we have a root, it means that the exponent is 1/3. So we look back at our our rules, and one of the rules is power, think multiplication. We can actually simplify this power right now. We can put it in the very front and call it 1/3. So I'm going to rewrite that. 3rd log. And then I've still got xy squared over z to the 4th. So I've still got some other powers, but I'm going to simplify them in a minute. We took care of the root. How about inside the argument? How many different bases do we have? So bases means the separate value that has an exponent. So the base is the bottom, and I have exponents. How many different bases do I have? They're like the factors. So what 2 do you see?
1/3 times x times y squared over z.
Okay, but so when I say argument, I mean this part in the middle. So just this. How many bases do you see? How many things with exponents do you see here? How many? 3. There's an x. What's its exponent? 1. Y with 2. And z with a 4. Okay. So I have 3 different bases. So when we expand this, that's what we're going for. That's what the directions would say in this case. It would say, please expand the logarithm we're going to have 3 different ones. We're going to have a third log base something, a third log base something else, and a third base log something else. Because there's 3 different bases in here. So looking back at my rules, if I see multiplication, I'm going to think addition. If I see division, I'm going to think subtraction. We have multiplication and division, okay? So anything that's on the top will be a plus. Anything that's on the bottom will be a minus, because these are exponents. So I'm going to make it a little bit easier. I'm going to put the 1/3 on the outside and just leave it, and everything on the inside will be multiplied by it, so I don't have to like do the 1/3 multiple times. So what I mean by that is, when we separated it, oops, I forgot my base was A. I need that base A in there. It has to stay A throughout the problem. So the first one's going to be log base A, and there's not a negative in front of it. You can put a plus if you want, just to keep it in mind. The very first one that's on the top is X, and I'm going to put X. It's to the first power, so I don't need to do anything else. The second one is also on top. I'm going to do the Y next. I like to just take care of the top and then move to the bottom. So I'm going to have log base A of Y. What's the power for Y? 2, and I could write it up here, but what's the rule for when you have powers? Powers means powers or multiplication. They go in the front. So instead of writing the 2 up here, I'm going to go ahead and write it right here. Sort of squeeze it in if you didn't leave very much room. And then since Z to the 4th is on the bottom, that means it's division. Division is subtraction with exponents. So I'm going to write log base 3. Oops, not 3. Sorry. Log base A. And then we're going to squeeze the 4 in there. Yep. So Diggs is like, you didn't leave enough room. And then Z is the base. And then the end bracket. So the 1/3 applies to everything just like it did up here. And you could multiply the 1/3 if you wanted to, but this is a good expansion. I like it. We could be done. You might see a book answer that says, like them all together, where you have the 1/3. 2 times a third would be 2/3. But they're both fine. Like, these are equivalent to each other. All right? So this used all the rules. And we didn't get to simplify anything, but we talked about expansion. Let's see some with some numbers. And before I start this, let's remember 2 things. Recall. If we see something like log 100 and there's no base given, what's the understood base? 10. So you could write this as a 10 there. It means log base 10, and you could even write this as 10 squared, right? So I wanted to remind us of some simple things. These are the same base, so this is actually equal to 2. So if there's nothing here, if this is empty, it means base 10. Also, the other one is the natural log. The natural log is the one that goes with that base of E for Euler's number. That number that's the natural population growth factor that Euler found in the 1700s. So this means base E. And the book won't put the E there because they're the lazy mathematicians who were like, I don't want to type something else. But you might want to write it in there because it'll make it easier to simplify things. So I would write in the 10 and the E, just because when you look at this, it's really easy to do this, right, and say 2. So I much prefer writing it in, especially as we're, still new at this. Okay, so let's simplify some more. let's say we're doing, this would be example 3, I think. Example 3. Let's actually be able to simplify this time. If we have log, and my argument is the stuff in parentheses, 27 times 10 to the 4th over x to the negative 2. I didn't forget the base. I just didn't write the base. So what is the base? 10. So we'll go ahead and add that in there. I'm going to add it in a different color just because it wasn't there originally, just so I can keep that in mind. Now, take a second and stretch this out. Expand it. There are 3 bases. Can you see them? What are they? 2.7, 10, and x. Excellent. So I'm going to pause the video. You write out 3 logarithms, and then let's just simplify it. Okay, see how far you can get, and I'll come back. So I'm expanding it. I don't need to write the 10 still, but you can if you want. So I'm going to say I've got 3 of them. Log base 10 of 2.7 plus, so this times turns into a plus when separated, log base 10 of 10 to the 4th minus this base, log base 10 of x to the negative 2. And I wrote this out because I really want to fix this negative 2 also. Part of expanding means that I don't have any exponents here. So this we could evaluate in a calculator. So we'll look at that in a second. This, I could write the 4 in the front, or what could I do with the second term? Yeah, so this cancels, and 4 is what this means. What power does 10 go to be 10 to the 4th? Well, 4. 10 to the 4th is 10 to the 4th. So I need this to be 4. That's the exponent. And then if we move the negative 2 to this one, I can't simplify this with x. But if we move the negative 2 to the front, it'll be negative 2. So this will be plus 2 log base 10 of x. Now let's think about this a little bit further. I would need a calculator to find this number, and I'll use a calculator in a second to simplify this. But what do you think this evaluates to? Is this power going to be bigger than 1 or smaller than 1? Like, what if this was 1? 10 to the first power, what would that be? That would be 10. This isn't 10, right? This is 2.7. It's smaller, right? So I must be taking this to a smaller number. I want you to have an idea of what logarithms mean. So this can't be equal to 1. It must be smaller than 1. 1 would mean 10 to the first power. This should be 10 instead of 2.7. So it's definitely smaller than 1. Let's find a calculator and see what it is. So if I actually type it in, log, and the button for log, the one that's on your calculator right here, is already base 10. And we'll play with some of those change of base in a little bit, how to put that in your calculator, but this is ready to go. That's why 10 is the common one. In the calculator, it's already automatically a 10. And if you type in 2.7, we get 0.43. So it's smaller than 1. But I want that to make a little bit of logical sense instead of it being like math magic where the calculator's like, ooh, it's 0.4. At least you know it's less than 1 because the power of 1 doesn't make sense. So if we wrote this out as 0.43, we could actually say that this simplifies to 4.43 plus 2 log base 10 of x. We might need to do some of this actual math to be able to solve things later. So separating it meant that we could make sense out of this 10 to the 4th, and even simplify the 2 to the 2.7 a little bit. But we would need a calculator for that. So we will use calculators more in this section than we have in any other section in the book. Okay, so we've done expansion. You have some problems for homework where you're going to look at them and go, if you see multiplication, you're going to separate with addition. If you see division, you're going to separate with subtraction. I guess I should write subtraction. If you see a power, you're going to move it to the front and make it multiplication. Okay, those are your rules written like really succinctly. Now let's try to apply it backwards. So let's go backwards. Okay, instead of expanding it, let's take something that's expanded and mash it back together. So we will call this example 4. Logically, makes the most sense. All right, so here we have 2 log base 3 x over 3 minus, log base 3 of 1 over y. So what we want to do is combine it. I'll let you write it down. I want you to digest it a little bit and tell me what things you see. Because we're trying to put, we just separated these. We're trying to put all those pieces back together. So we need to somehow get the arguments together. We need to reconcile this 2 somehow. So what do you see? What things can we do?
You can square the number 3.
Okay, the whole thing, right?
Yeah,
this means goes up here, so the whole thing is squared. So definitely we want to do that. So if I rewrite it just because it's messy, I would have the whole thing squared. So x squared and then 3 squared. Good. Okay, now what?
You can change that fraction for
Okay, so this minus in expansion means what when you put it back together? Multiplication, addition, or subtraction?
division.
It means division. That gets a little bit tricky because I've got a fraction divided by a fraction. That's actually the rule. That's what we do in most of the cases. But what if I fixed it like I did for this other problem? There was one a minute ago. This squared up here, where it was a -2 and I changed it. What happens if we change this and make it, what could you make 1 over y? What exponent could it have? -1. What if we redid that? What does that do for me? If I do it like this and I move the -1 to the front, doesn't that make that positive? That would make it just a little bit easier. Let's do that. So this first example is a little bit tougher, but I think if we move it to the front and we said, okay, there it is. Now it's addition, it's way easier. So now we're ready to combine them together. We have the same base. We don't have anything in the front because it's just 1. And so we can write it in 1 logarithm with a base 3. You don't change the base or add it together or anything. You just keep the base. And then we're saying the first one is x squared over 9 times y. And you could write it as x squared y over 9. That would make sense. But the idea is that this one with the plus sign is multiplication. So the plus turned into multiplication right here. Just like up here. It was addition and went to multiplication. So these are like arrows that go back and forth. But it depends. It has to be in the right sort of situation. Let's try that again. You put this one together. This says the natural log of x squared minus 1/2 the natural log of y plus the natural log of 2. What's convenient about this one, example 5, is that because it's the natural log, it's shorter to write. Like it's just natural log to write. ln. That's all you have to write. So I want you to look at this as 3 terms. That means there's going to be 3 things in the argument. If you have any numbers in the front, you should reconcile those first. And then you want to combine with multiplication and division. So I would get rid of the powers, fix the powers first, and then change to multiplication and division. Can't move my mouse. So I was suggesting that we take care of this first. We put it up here. And now we have 3 bases with nothing in the front. So I'm going to write natural log once, and I'm going to put everything in the argument. This one is positive in the front, so it goes in the top. That's how I think of it. This one has a minus, so I put it in the bottom. Okay? This one has a plus, so I put it in the top. It's in a weird order, but that's fine. I've done everything in the right place. Plus means put it in the top, multiplication. Minus means division. Plus means put it back in the top. You might see this answer written in the book like this: 2x squared over the square root of y. These are the same thing. I accept either. They're both fine, but I want you to see that, there are other ways to write the problem. Y to the 1/2 means the square root. Sometimes you'll see it written like this. Whenever you see a square root, you need to write it as a power if you're trying to put it in the front. That's a trick on purpose to see if you can turn that into an exponent. So watch out for radicals, because that does mean an exponent of some kind. So what we've got for homework is simply writing back and forth to get used to what we're doing here. Let me do one more tricky example, because sometimes they mix up the addition and subtraction. So let's look at this. Example 6. Let's do another natural log one, just because it's easy to write. I'm going to say I've got x plus 2 times y squared over x minus 4. So I'm still trying to, I went back to expansion. I'm going to expand this, because what I want you to notice is the base. I have messed this all up a little bit. I've mixed up the multiplication and addition. And the reason for that is this. Remember how things in parentheses are a unit? This is one entire base. It has to stay together. So this is one base. Y squared is the second base. And then x minus 4 is the third base. And it could be anything. It could be x to the third minus 4. It could be, but when it has a minus sign, that means it's a unit. It has to stay together. So if you're going to separate these, you're going to have natural log of this one plus natural log of this one minus natural log of this one. So do you see how this is a whole unit? Just because there's a minus and a plus here, they don't change to like multiplication and division. It's weird how this works, but we're only looking at things that are multiplied or divided in here, and that's what we separate. So I'm going to write it out. Natural log of x plus 2, and I'm going to use parentheses so that I keep the whole unit together. And then a plus, because y squared is also on the top. I am going to put the 2 in the front, if you're okay with me sort of doing it all in one step. And then this guy's on the bottom, so it gets a minus, and then the natural log, and keep the x cubed minus 4 together. So it might be handy when you write the original problem, and I do want you to write the original problem and then either expand or condense it, because that's part of writing it down, is recognizing things like the bases. But I would go ahead and circle stuff, okay? So when you put this back together, if you saw it this way, you would say this is a base. Like, it's not this, the base is E, but this is a unit. This is a unit, this is a unit, so I'm going to put this and this on the top because they're positive, and this on the bottom because it's negative. So I want you to see those units, and maybe you should put a box around them or something to make sure that you can't expand this with multiplication. It doesn't, even though I have multiplication goes to addition, it's not willy-nilly, there's an order to it. And it only happens when there's multiplication within the exponent that you can subtract, you can separate it with addition. And it takes practice to get that. So can you see those units? I think practice will help us see that better, but I wanted to make that point for you for what we're doing. So your assignment is these problems. This is on page 437. You've got about 15 minutes if you want to go ahead and get started. You can ask me questions. I've got 1 through 12 and 19 through 27. So the first ones are expand and the second ones are condense. And that's really all we're doing because it's easy to get them a little bit confused, and I want us to just focus on that, and then we can work on really simplifying things tomorrow. Okay?